Hello friends, you are watching Analytics Diksha and I am Akash Goyal. So this video is on Perceptron visualization. So let's understand one point. Whenever we do any task in machine learning, we are actually learning the weights. And whenever we learn the weights, actually we are learning some decision boundary. So this video is to showcase you like how the decision boundary adjusts itself to classify the points. So this video will show you like how those weight update happens and how those learning actually happens. Now let's go into the code. So this is the first cell where we are just importing the libraries, and now second we are now reading the data. So this is the name of the file, and it actually contains 100 rows and three variables, three columns basically. So this x1 and x2 are your independent features and y is your target variable, and you can see that it contains two unique values, either 1 or 0. So 50 rows for one label and 50 rows for label 0. So we want to train a classifier which basically classifies these points in either into 1 or 0. Now this is just simply I am plotting these points on the x1 and x2 axis. Okay, now let's see how we visualize those weights, how we basically firstly update the weights. So there is a perceptron trick for that. So the first trick says that, let's say this is the line guessed by your model, and it says that anything above this line is actually blue and anything above this line is actually red. But we are seeing that we have misclassified this red dot. So in order to correct this misclassification, we need to take this line closer to this, or in other words we need to take this line away from the origin. So in order to make this point as an correct, we subtract the coordinates of this point from this line. So like we are subtracting the coordinates and we are multiplying those actually points with the learning rates. So 4 into dot 1 is 0.4 and 5 into 0.1 is 0.5, and hence we subtract. So this is the new line, and it, if you draw it, it will be actually far from the origin, and hence we correct this point. And the perceptron 2 is just opposite. So here we want to correct this misclassified blue dot, so we need to take this line towards the origin, and hence to do that we actually add this point, and this is the new line. And if you draw, you will find that this line is closer to the origin. Now let's see how above description we have coded. So this is the function which actually train your perceptron, and if you read the comment, it actually runs the algorithm repeatedly on the data set, and it runs 100 times as the number of epochs is 100, and it actually returns the boundary lines. So what it means, so you can see here it is running the perceptron step as a function. So this function is actually updating the weights, right? So it is updating the weights and returning the weight and the bias, updated weight and bias, and we are storing this in the boundary underscore lines variable of type list. So as we are running through different number of epochs, we are learning some weights and bias. So the same is we are storing in this boundary lines, right? And if you see the working of this function, it actually doing nothing much else than it is just predicting. And if your prediction is opposite to your true label, so it is using the plus sign, it means it is using the perceptron trick 2, and if it is using the minus, it is using the perceptron trick 1. So it is actually based upon this if and else condition. Now once we run this cell, actually we run the train perceptron algorithm, and in this boundary lines we get the updated weight and bias for all the 100 epochs. And if we scroll down our code, you can see we have ran up to 100 epochs, and it actually started from 0, that's why it is 99 here. And if we just print the first index of boundary line, so this is the slope of a new line and this is the intercept of the new line, right? Now this is the code. So in straight lines we have studied that we draw y is equal to mx plus c. Then so we have the slope and we have the intercept. So we can draw this line on the Cartesian plane using some fixed set of values of x. So this is the functions which do that. So under matplotlib there is an animation function which actually doing the same thing, which calling the function animate and for the 100 times, which is the number of epochs, and it actually updating your line, which is the nothing else than your weight updations. So after this updating your lines and drawing on the plane, we can save those GIF. So basically we have ran for 100 epochs, and for each epoch we are getting the weights and bias. So basically we are getting a new line for each epoch. So all the epochs, when we complete our run, we are saving into the form of GIF. And if you can see here, we ran that GIF into this, embed this GIF into our Jupyter Notebook. And if I just scroll down, if you see, as the number of epochs is rising, the y is equal to mx plus c is changing, and it is changing in such a manner, or rotating this line in such a manner, that your blue and red points are getting separate by this line. So anything below this line is your red, and anything above this line is blue. So this is the way of visualizing like how the learning happening. So basically we are learning this line and adjusting the weights so that we can classify this red and blue points. So if you have any doubts, please write in a comment section, and please subscribe to our YouTube channel. Thanks for watching this video.